Hey, I'm Cully, aka Flossy Purse, and this video is going to cover batching. Specifically, the batching feature we have with the Resonate Python SDK. So, real quick though, let's talk about the problem space. Just so we're on the same page, when we talk about batching, we're referring to the practice of grouping multiple operations into a single unit of work. Why would you want to do that? Typically, there's two main categories of reasons. Speed could be just a lot faster to do it that way. And the other is resource utilization, which ultimately can translate to savings in cost, especially with any infrastructure where you're paying for what you use. Then using less resources equals less cost. Okay, so at smaller scales, this type of optimization might not be necessary. But when you get into really large scale workloads, efficiency becomes pretty key, right? So, for example, processing 100,000 operations sequentially could be far more costly and time consuming than batching those same 100,000 operations into a single task. Of course, we have to assume that whatever resources you're using, let's take a database for example, supports the ability to do some batched operation. So let's focus on a concrete example. Consider an application that creates a row in a database for each new user. If that application gets less than one new user per minute, or even every 30 seconds, or maybe even 10 seconds, then it can probably handle sequential inserts. Basically, there's not going to be a real problem there with your application committing those users to the database and creating bottlenecks. It's probably going to be just fine. But let's imagine a scenario where suddenly this application becomes incredibly popular and you have a spike in new user signups. And you're suddenly getting 1,000 new users per second. The database would save to durable storage on each query that comes in. And the application probably wouldn't be able to keep up with all that demand. Every second, there would be a longer and longer delay for users to get added to the database. And we can imagine that pretty quickly, a lot of the new user signups coming into the application would time out, waiting for their turn to get into the database. Here we can see what that very basic SQL query would look like, what that function would look like, right? So in this very simplified example, we might now consider batching SQL queries so that more rows are created per commit. It would look something like this, where we'd create users in batches. And if we can batch thousands of queries into a single commit, then likely the application would be able to keep up with that demand. In theory, that sounds great. In practice, now we have to manage the complexity of coordinating these otherwise concurrent executions to collect a batch. Sounds like a trade-off, right? Well, let's look at what Resonate provides. Okay, so with Resonate, we get a handy set of APIs that helps coordinate all of those concurrent requests into a batch. So first thing we're going to do here is we define a data structure. And the key thing about this data structure is to initialize it with what Resonate calls a command. just like this. And if you use Python's data class library, it becomes pretty simple. And this is the data that will get inserted into every row. Next, we're going to define a handler. And this is going to look familiar. This is basically that same exact code where a list of users gets committed at once. So for user and users, we insert them and we don't commit until after that list has been iterated through. Next, we're going to need this top level function that makes a local function invocation and passes our data structure. So this will pass, every request that comes in will pass that data structure to the Resonate SDK. And the Resonate SDK will coordinate all those requests and put all of those bits of data into a batch. Last, what you need to do, register this top level function and register the command handler alongside the data structure. Here's the data structure, here's the handler, and that way the Resonate SDK knows to match those two up. That data structure matches with that handler, and then it will be able to coordinate all of that data into batches. And down here is where we run the top level function. So you can imagine if this was an HTTP server and a create request would come in, you would call resonate.run create user batching, which is calling this function here on every request, passing in the data. In this example, we're gonna just mock this out with 1,000 users. 1,000 users need to get created. Each one, right, calls resonate.run. So mimicking a per request situation. So they're concurrent individual requests coming in, and we're calling resonate.run on each and every one of them. So let's make sure our application is set up. I like to use Rye these days. Let's run it. And we can see from the output that Resonate batched 408 users, and then the next batch was 718, 1514, etc., etc. All the way up to the largest batch was 2,690 users at once were inserted into the database. Okay, but the question is that actually more efficient? So what we're going to do is we're going to set up a benchmarking test. And to do that, we will expand our application to support both sequential inserts as well as the batched inserts. So let's go back and look at our application here and we've added the sequential insert. So here's our top level function that we're going to register with Resonate, which is create user sequentially, making a local function invocation to create user. And you can see this is very similar to the original function that we were looking at, where it just does a single insert and commits after. And then we've also got our batched logic here, which is also registered. And here we've expanded the application into a very basic CLI tool. So every time we run it, we can pass these arguments, batch or no batch, and the number of users we want to insert at that time. Here, we're going to measure the time it takes to complete these operations from start to finish. And that should give us a really clear idea of the level of efficiency, at least in terms of speed. And then back up here, if we look at our insert statement, right, we can see that on every insert for our sequential create user function, it's going to print user has been inserted to the database. And our batch handler, it will do the same for the number of users that have been inserted. And so that will give us an idea of efficiency in terms of resource utilization. So we've got an ability right now to benchmark both speed and resource utilization. So let's run this and see what happens. Okay, so first, let's run no batch and users is 1,000. .49 seconds. Let's run this same number of users, but with batching true. And that took 0.06 seconds. And you can see there was only 2 commits. Let's increase the number of users and see what happens. So no batching, let's increase it to 10,000. Okay, inserting 10,000 users took 4.2 seconds. Now, let's do a batch with 10,000 users. There, 4.2 seconds versus 0.7 seconds with batching. And 1, 2, 3, 4, 5, 6, 7, 8 commits. Only 8 commits versus 10,000 commits sequentially. So you can see that in this example, batching is much, much more efficient. You can imagine if we increase that number to 50,000 or 100,000 users, that the batching capabilities would have more and more impact as that number would go up. Thanks for joining me in this video. If you want to learn more about the Resonate Python SDK, visit our website, resonatehq.io, and you can sign up for the Python waitlist or visit the webinars page and sign up for one of our upcoming webinars. Thanks again, and we'll see you out there.